Happy Friday, everyone. We're now to the point of this geometry unit that we're kind of closing things out in terms of working with more specific things such as conics, um, locus problems, which of course lead to the conics. We then move into um, parametrics, which all of us in BC recently worked with, and then eventually looking at conics again in terms of parametrics and some of the geometry we had previously, and even some of our linear algebra to be able to rotate some of these conics and equations. So today will be a very short reminder of some things about parametrics. First and foremost, when we have a parametric, we know it's kind of a third variable to represent or connect to other variables. And so some of the things we're expected to do with this is to make some conversions. That's probably the biggest. Now, when we talk about conversions, we could go a couple different ways. We could have what we could call rectangular, and to convert it to polar or parametric. Or we could have, of course, parametric and convert it to polar. And that's going to be the one that we'll spend most of the time on. If we have rectangular and we want to go to parametric, we just have to realize it's not unique, so we tend to let one of the variables be the t or the theta and then go from there. The ones that connect the trig parametrics to the rectangular are the ones that are probably the most common. For example, let's say we have a parametric set of equations where x equals 2 cosine theta and y is going to be 2 sine theta. Now, just as a reminder, we know that we can grab our calculators, go into parametric mode, and graph these functions, or graph this function as a set of parametrics. But if we want to know what it looks like even before we get to that point, we can simply just take x squared plus y squared and hope that we can then see the conversion. So this would be a rather simple one. We know we can factor out a 4. We get sine squared plus cosine squared, it's 1. So we get x squared plus y squared equals 4. So yeah, this thing is a circle. It's a circle in rectangular coordinates, and it's a circle in parametrics. You might then go one other step and think, can we write it in terms of polar function? And of course we can, and it would also be a circle. So that's one example. Here's another one. Let's say we have these two, where we have a x equals 1 plus 2 over t, and y would equal 2 minus 3t. See if that works. Okay. Now, if we want to change this into a rectangular, we of course could just solve for t in one of them, but it's kind of fun to see if there's some insight to group these so they might look a little bit nicer. And here's an option. This one I can just rewrite as x minus 1 equals 2 over t. Here I could write y minus 2 equals negative 3t. And then if you look closely, if I just have equals multiplied by equals, I would have x minus 1 times y minus 2 would equal 2 over t times negative 3t. Nice thing about that is the t's cancel without any real type of substitution. So now I just have to simplify this, and we get xy minus 2x minus y plus 2 equals negative 6. So we're going to get, if I rewrite it in a little bit different form, negative 2x plus xy minus y equals negative 8. Might change all the signs just so it looks a little nicer or different. I did that right. And whatever that is, going to be our function. Now, we could try to solve for y by doing some special things, but for now, that would be enough. So converting from a set of parametrics to rectangular is something you will practice here in this problem set. Another thing that you might remember from calculus is derivatives. Because there are some problems here in this problem set involving tangents to a certain curve. Now, anytime we want to find tangents to a curve, we know that calculus could play a part. There are some nice examples in this section that would illustrate how to go about that without calculus. I think they can be very valuable. But if you fall back on the calculus, there's no problem at all with that. In order to do that, however, if I wanted to find, for example, something tangent to this curve, I could change it to rectangular and then work with it as a rectangular function. However, it's nice to also be able to find the derivative in terms of the parametrics. Now, we know that if we, for example, wanted to find dy dx, and let's say it's all in terms of t as the parameter, we understand that that's just dy dt divided by dx dt. These notations really, remember, are not strict fractions, but they behave like fractions in many ways. And then we could go ahead and figure this out. So if I wanted to find the slope of the tangent at a certain t value, I would have to go back and figure out that t value from the x and y, or the x and y from the t value, and get that slope, that derivative. There are different ways to write it, but the parametric differentiation is something that you could be expected to work with. There are problems in the problem set that mirror the examples that you can study. As I mentioned before, I don't want to pretend that these videos are going to enlighten you too much more than what you could get by reading. It's more of just touching base. One thing I will say, that as you work on the handouts that I've posted, and then hopefully you'll get to me as soon as possible, if you have questions, please send an email. I can either talk you through it, or better yet, I have no problem taking one of those or a problem very similar and posting a very quick 5-10 minute video over a couple of those that you might want to see. So please do not hesitate to ask me to do that. This is a course that, because of the type of students all of you are, I know that you're able to progress, and in some ways you just kind of wait for those worksheets that you know will be given to me and graded to make progress. As far as the IB course itself, there's been some changes in terms of testing. For example, any class that has an internal assessment, that's going to go a long way in deciding what the IB grade here is. In this class, we have yet to get any specific information on how a course that has no internal assessment is going to be handled. So for now, we're just going to make progress. In a couple weeks, we'll basically be done with this geometry unit. I will post a rather large test, quiz, take home, whatever you want to call it, that you'll have several days to work on and return to me. After that, we'll fill the time with a variety of things, maybe acting like we are testing even if we don't, and maybe get into those IB questions and problem sets that you've been working on, pretty much throughout the year. So for now, let's just stay focused on wrapping up the geometry, continue to read, continue to stay in touch, not only with me, but with each other. And good luck. I hope all is well, and enjoy your weekend.